Hey guys, today we're going to do a video on parent function characteristics. So as you can see here, and as always, pause your video anytime you need to. I've gone ahead and put in your parent function and your graph for each of these parent functions. I will go ahead and tell you, you are expected to know the equation, the graph, and all the characteristics for each of these parent functions. When we have a test, I will select some of these to be on your test, and you will be expected to know them. Now, the easiest thing to do is understand how to read your graph and not memorize the characteristics. Because if you can remember the function, equation, and the graph, and you can read the graph, then you can find the characteristics. Linear function, f of x equals x. Your graph is a line. It is a linear function. Your domain, no restrictions. Your range, no restrictions. Your x-intercept and your y-intercept are 0, 0. The maximum number of roots and zeros is equal to your exponent. So 1, it's also the number of times it crosses the x-axis. In behavior, as x approaches infinity, f of x approaches infinity, as x approaches negative infinity, f of x approaches negative infinity, and it is a continuous function. If you have questions on any of these, make a note and we will talk about them. Domain, no restrictions for absolute value. Function, f of x equals absolute value of x. Range is a bottom up. Notice on these, everything will be written in interval notation, no inequalities. X-intercept, y-intercept, both 0, 0. Maximum number of zeros, this one's a little tricky. The maximum number of zeros is 2, because if I were to shift this graph down, it would touch the x-axis in 2 places. So you might want to make yourself a note of that. These will always be as x approaches infinity and x approaches negative infinity, always. And then you fill these in. So as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches infinity. And it is a continuous function. Quadratic, f of x equals x squared is the graph of your parabola. No restriction on your domain. Your range is a bottom up, so 0 to infinity. Your x-intercepts and y-intercepts are 0, 0. Highest exponent is 2. Maximum number of zeros is 2. Again, if you were to shift this down, it would cross the x-axis in 2 places. As x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches infinity, and it is a continuous function. Again, guys, learn how to analyze these graphs, and then this part is simple. Cubic function, f of x equals x cubed. Here's your graph. No restriction on the domain or the range. X and y intercept 0, 0. And remember, this is for the parent function. This is not for all. Maximum number, roots and zeros. Infinity and negative infinity. As x approaches infinity, your graph approaches infinity. And as x approaches negative infinity, your graph approaches negative infinity. And it is a continuous function. Taking a look on the back, square root function, f of x equals the square root of x, and the graph that you see here. Domain and range both have a restriction because, as you can see, this graph is only in quadrant 1. It includes the point 0, 0, so 0 to infinity for both. X and y intercept 0, 0. Maximum number of zeros is 1. If you were to shift this down, it's still only going to cross 1 time. Infinity and negative infinity. As x approaches infinity, f of x is going to approach infinity. But this can't be negative infinity because I don't go to negative infinity. So this has to be 0. As x approaches 0, your graph approaches 0. And this function is continuous for x greater than or equal to 0. Cube root function, f of x equals cubic root of x. Here is your graph. We do not have a restriction on the domain or the range. Your x and y intercept 0, 0. Maximum number of zeros is going to cross one time. As x approaches infinity, f of x approaches infinity, and as x approaches negative infinity, f of x approaches negative infinity, and it is a continuous function. Starting with reciprocal and going all the way down to the end, you will see some things highlighted. These are asymptotes, and you need to make sure that in some way, shape, or form you have made them kind of pop. You need to make sure they are part of your graph. If not, your graph will not be correct. Reciprocal function, f of x is 1 over x. 1 over x has a horizontal and a vertical asymptote. Horizontal asymptote at y equals 0, vertical asymptote at x equals 0, and it is in quadrants 1 and 3. So your domain is x cannot equal 0. Your range is y cannot equal 0. There are no x or y intercepts. The maximum number of roots or zeros, if we were to shift this up or down, would be 1. As x approaches infinity, f of x approaches 0. As x approaches negative infinity, f of x approaches 0. It is a discontinuous function, and you have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. This is a function you may not be as familiar with, so it may need a little more attention when you go to study. Exponential function, f of x equals 2 to the x. Its asymptote is horizontal, and you can go ahead and fill that in if you'd like. It is horizontal at y equals 0. It is an upward shaping curve, so it has no restriction on the domain, but the range is from 0 to infinity. Remember, you have that horizontal asymptote here, so it does not include 0. You have no x-intercept, and your y-intercept is at 0, 1. The maximum number of times it can cross is 1. And as x approaches infinity, your graph approaches infinity. As x approaches negative infinity, your graph approaches 0. It is a continuous function. And finally, logarithmic. We are going to do a whole chapter on logs next. So this is kind of an intro to that. F of x equals log of x. Your asymptote is vertical at x equals 0. Again, you have a curve that goes up, but it is in quadrants 1 and 4. So this time your domain has a restriction, 0 to infinity, and your range does not. This time your x-intercept is 1, 0, and you have no y-intercept. The maximum number of roots or zeros is 1, and as x approaches infinity, your graph approaches infinity. And as x approaches 0, because it doesn't go beyond 0, your graph approaches negative infinity. It is a continuous function. So this one is a little strange for end behavior, as is your square root function. This is material that you are responsible for. So if there's something that you have a question on, please make sure that you ask. If you need help with interpreting the graph so you don't have to memorize all the characteristics, I'll be glad to help you with that. So this concludes our functions chapter for the second functions test, which will include piecewise functions, transformations, and parent functions. If there's something that you need help on, let me know, and I'll talk to you soon.